Introducing the Space Junk 2000, a scanner that spins in a circle moving slowly, really slowly upward. And this thing, it's not perfect, but I'd like to show it to you so you can at least understand how it works and how it's useful. So here in our debug panel, every time it comes across a new object, it debug prints the position of that object. Now this isn't a precise position because we're detecting static objects. We do not have objects tagged here. And so what this means is this is going to be accurate within about 1 meter. We need to discuss some other ways to find objects because oftentimes your space junk looks like this and it's super far away and you zoom out to 500 and you don't know where it is. So the best way to find space junk is to click one time and hold. The minus and plus sign appears. Now joystick to the right, and now you can make your symbol even bigger. And then you scan the area using this. Now this is what I use when I'm searching for space junk, and I'm still going to be using it. This radar is super cool if you really need to find something, but this is definitely the easiest way to find space junk. And obviously there's no space junk because this was an empty world, but once you find it, now it's selected. So the space junk that this thing really allows you to find is locked objects, because look at this. If we lock this object and come through, it doesn't select it. So if there was a tiny locked object, we wouldn't be able to find it. So I theorize if we click with our lock button, we can now unlock. Did that work? So we go back up here, scale. No, it didn't work. Okay. There's no easy way to unlock objects. So that's what this radar really is key for, is finding locked objects that are lost in your world. Now, the other thing that I wanted to quickly test here was, does this hit? It's coming through and, oh, it did detect it. So this is awesome. It did detect this animated object, and that is fabulous. Then the next question is, does it detect collidable animated objects? So we're going to go ahead and move this over right into its path. Non-collidable animated objects, does it go off? And it does go off, so it even detects non-collidable objects. That is fabulous. So we're going to go ahead and delete this one. As you can see, we have this object with a raycast on the tip. It's pointing out and it's slowly spinning. And now this might not seem slow, but I actually have this running on local scripting. So it's running, 60 frames per second. So it's doing 60 iterations per second. It seems really staticky. And this is where I think we're going to see some issues, is if you go way far out here on like the reaches of the 2000 end, I'm wondering if it's skipping like a meter. So if an object is really far away, we might need this to move even slower, but I'll go into ways that we can do that. Here you can see it's slowly moving up. You can actually change how fast it moves up and where it moves up by using these control points. So you have this top object represents the upper position, the upper bound of this search. And so if I bring it up higher, then you're going to see that this will actually be moving substantially faster upward. And now it's pretty hard to see, so I'm going to hit undo on that. But that is pretty cool too. You can see that these objects are just plain old static objects, and when it comes through, it's going to detect them, and it's just an object with no attributes on it. And then on our, let's go and look right here at the raycast, you're going to see that this is just running on objects tagged, and there's no tag. Raycast is since 2000, and so that's what we're doing here. Now, this is pretty cool, and I believe I've also set this up that if you wanted to look down and up rather than doing up and down like we have it here, you could actually, let's go stop the world so I can show you this. So we get stop, reset, clear. It's really important that you only interact with this when the world is stopped. So we're going to point it like this. So if you didn't see that, I rotated it like this way and then this way. And then I grab these positions and I'll move them from one side of the grid to the other. Now the positions of those aren't relevant to the rotation, so we'll hit stop, reset, play. Now because we're using local scripting, as it turns out, it should still be connected to my headset. And yep, there we go. So now we're getting a rotation along this axis. So if you really wanted to just look down and up and along this way, you can do that as well. And of course you could move this further out. As you can see, it's really moving quite slowly along this, so we can actually interact with these cubes. Just got to be careful. If we touch that spinning triangle, we're going to get some issues. Yeah, look at that. It follows along, which is pretty cool. And so that's how that works. Now I'm going to go ahead and stop the world so I can reset everything back to its original position. So stop, reset, undo, undo, undo. Sweet, so I'm going to hit stop then and reset while we work on this. And so now if we come down here, you're going to notice we have two scripts. Assigner is a very simple script that I'll just show you right off the bat. So Assigner says when world is entered by player, if once per, so we have a Boolean variable that's set over here under variables tab, it's automatically set to true. When that comes through one time, we set once per to be false, so that way this only goes off for the first player to enter. We then transfer ownership of the scanner to the first player to enter. Now that the scanner has been assigned to that player, it's going to run that script. So if we come on over to the space junk script, you're going to note that if we go to our settings gear, you can see that it's a local script. And this will start, this when world is started will go off when the object gets assigned to the player. And so that's when we send assign player ID to self after 1 second and send my event to self after 2 seconds. And assign player IDs transfers ownership of the raycast, the position 1, the position 2, all to the owner of self. And so we don't need to figure out which player ID. We just know that it's the owner of me, and because we transferred ownership already. Perfect. Now in my event, we have a move command, we have a rotation command, we have an iterator, which allows us to iterate up slowly, we have a raycast, and so I'm going to run through the raycast portion because this is the part that really matters. And so what's happening here is we send off the raycast with the raycast block, so we have an object variable which is for the raycast, and so we send it off, and then it makes that raycast go off. We then say if the hit point from the raycast doesn't equal 0, 0, 0, and if the distance from the current position to the hit point from the raycast is greater than 3, meaning it has to be 3 meters further from the current position, we then set the current position to be that of the hit point. And so what you're going to notice happening in here is we're getting the floor of the X, the floor of the Y, and the floor of the Z. And the reason we do this is so that we don't get really minute numbers like 0.11111. We were getting like literally hundreds of entries, and we wanted to make sure that we were only getting 1 entry per object. And so that's what this does. So that's why we're getting these as floors. And then we debug print the current position as a string. Fairly simple. We then send my event to self, and we don't do it with a delay. It's just happening as fast as locally scripted possible. And now up here on our motion, the way this is working is we're using the lerp command. Now lerp can be found under the operators tab, pretty close to the top actually. And so here you go, right underneath floor actually. So there's lerp. And what lerp allows us to do is move between 2 positions. We have the position of position 1, we have the position of position 2. We have iterator being multiplied by 0.001. This just basically allows us to make it move extremely slow. So we're using this percent symbol so that when it reaches 100%, it loops back to 0, because this gives us the remainder. That's what this percent symbol does. So say it was at 1.2, then it would return a value of 0.2. And if it was at 2.2, it also returns 0.2. Super valuable, very useful, found at the top here, right underneath basic operators. Then we rotate self by a new rotation of 0, and then we do I remainder 360, so that way we're going a rotation of 360 degrees over 0.1 seconds. Now this 0.1 seconds isn't actually necessary because it's going so fast, but it was useful in the early iterations. And then here you can see we're setting the iterator value to be I plus 0.0001. And again, all these 0 1s are doing is basically just making this more refined, slower as it goes. And this could actually be slower, believe it or not. And then over here on our variables tab, you'll note that we have the raycast object variable, we have the iterator number variable, the 2 position object variables so that we can move the positions around, and we have our current position, which is just a vector variable in motion. All right, that's it. If you have any questions, do not hesitate to ask. If you'd like a copy of this, feel free to just ask. We're giving it away freely. Make sure to like and subscribe, and we'll see you in Horizon. Bye!